we're going to start with number 1 here, since that has 4 votes, and or 5 votes actually. I wrote it. And one of the first questions, folks, remember you don't have to pay attention to work on other problems. Try to keep it down a little bit so I can hear myself think, and other people can hear me if they need to. The first question to ask yourself on all of these is this a situation where it's a system and I have before and after? And the question on this one is yes, because we have multiple objects. We have 2 boxcars, and those would compose a system. And there's a situation where they're moving before, they're separate, and then they become one thing afterwards. All right? So it is a system, and it is a before and after, and so that should trigger in your mind, I need to do a diagram on this one, or I'm going to lose, like, 40 or 50% of the credit for the Y. All right? So make sure you look at that rubric. So we got the one boxcar moving, strikes the second that's at rest. The 2 stick together and move off with the speed, mass. What is the mass of the second car? So, start off, number 1. I would start off with, let's see, the 2 cars are a system. And that's really important because I know that momentum is conserved in a system. So it's really important for me to make sure I identify what the system is so that I know that within that, I know that momentum is conserved. Remember, if I don't, it's not conserved for the individual parts of the system, but for the system as a whole. And then it might also be good to make sure that you show that you understand what momentum is, even though at this point, hopefully you do. Momentum is inertia in motion. So, text-wise, those are the 3 points that I would say make sure that you get in there. There are, you could put other things. There's lots of other things that could go in there. Now I need to do my diagram. Let's see, how do they distinguish between these 2? First and second. So we'll call it 1 and 2. The 9300 we'll call 1, and the unknown we'll call 2. They don't really distinguish one from the others. So I'm going to draw boxcar number 1, boxcar number 2, and then afterwards they become a conglomerate of 1 and 2, or 12. So 1 had momentum in this direction. Call that momentum 1. Momentum, I don't like that. Momentum of number 2 beforehand equals 0. This dotted line, remember, would represent them running into each other. And then together, they're going to have momentum. I'm going to predict it in that direction afterwards. Okay, good. So, my Y is complete. I'm ready to move on to my how. I'm going to use that second statement there to start me off. Momentum is conserved in a system. And from my equation sheet, I will grab the momentum of a system equals the momentum of the system afterwards. And I think one thing that's good to note in our drawing, how many objects do I have beforehand? 2. How many do I have afterwards? One. That, for me, helps me lay out this, to not forget something in the system. So, beforehand, I have the momentum of number 1 and the momentum of number 2. And that's going to equal the momentum of 1, 2. All of these are vectors. And so I've got 2 objects in the system before. I have 2 momentums in my before part of my equation. 1 object after, 1 momentum after. And then I start going here and now use my equation that momentum is inertia times velocity. That's also from my equation sheet. So I have inertia 1, velocity 1, plus inertia 2. Oh, wait a minute. I know what momentum 2 is, right? It's 0. I said that in my y, so 0 equals inertia 1 plus 2 and velocity 1, 2. Because they're one objects, they have the inertia of both objects in them. And let's see what I know. Excuse me? Sorry, just couldn't hear you. It's not velocity 1 times 2. It's the velocity of object 1, 2. 1, 2 is the name of an object. You could rename it and call it like bomb. Then it would be the velocity of bomb. Yeah. But it's just the name of it. Alright, let's see what we know here. We know the inertia of the first one, 9,300 kilograms. We know the velocity of the first one, 21 meters per second. We'll assume that's in the positive direction. We know the velocity of the 2 of them together afterwards, 13 meters per second. Alright, so let's fill in, and hopefully the only thing we'll have left to find is the inertia of the second one. So, M1, 9,300 kilograms. V1, 21 meters per second equals 9,300 kilograms plus M2 times 13 meters per second. Oh, good. All I have to do is the math, right? Get M2 by itself. You guys see how to do that? Yeah. All right, give it a try. Let me know if you need help on it, and in a couple minutes we'll go on to the next one. Yep. No, because 13 is multiplied by everything else on the right side, you divide both sides by 13, which doesn't change the sign. One intuitive thing to look at here is to think about when I'm predicting my answer for M2, do I think M2 is bigger than, equal to, or smaller than 9,300? And the thought process I go through is I looked at 13 and said, well, 13 is more than half of 21. If the 2 cars were the same size, I'd expect it to slow down and be going half as fast because it'd have twice the inertia. So I think M2 is going to be less than 9,300 because it doesn't slow down to half as fast. And it turns out I'm right. I got about 5,700 for mine. So, if you can see that, that can be a great help. If you can't see that, practice. I just went through like a 2-minute explanation of why I predicted I would get a smaller number than 9,300 and how I did. Huh? Huh? Sure. All right, so so we're going on to number 3 here. Did this problem seem vaguely familiar to anyone? It was from the video. Yeah, I picked this one because it lined up with the video that some of you watched. Those grades will be going in, so if you haven't watched it, you might want to, and then email me, hey, I caught up on my work. All right? So we got this gun fired vertically into this block of wood. The bullet has the mass of this and the speed of this. How high will the block rise in the air after the bullet becomes embedded in it? So, do we have a system here? Yes. The bullet and the block are making up a system. Can you close that file drawer that someone left open for safety? Is there a before and after situation? Yes. So I need a diagram, right? All right. So let's think about our Y here. This is number 3. And again, I'd probably want to define momentum. Momentum is inertia in motion, or however, whatever wording you're using. It's not the best one, but the bullet and block are a system, and momentum is conserved in a system. I'm going to start writing smaller so that will fit in there. And I could put in here that there's how many objects before the interaction and one afterwards, or I could just show it in my diagram, right? So you might write it, you might just show it. All right, so here's my diagram. All right, so I'm going to have my bullet and my block, and that's going to be the momentum of the bullet, which I'm going to call B, and then the momentum of the block, which I'm going to call L, is 0. Afterwards, I've got the bullet and block, my object, BL, and it's going to have a momentum in that same direction. So, okay, I thought you had a question, but let's use red. Fine. Can I start the exact same way as last time? I have 2 objects ahead of time, so I'm going to look at the momentum of the bullet plus the momentum of the block equals the momentum of the bullet that's lodged inside the block, so BL. And this would be the inertia of the bullet, velocity of the bullet, plus 0. Again, my block's not moving. And that's going to give me the inertia of the bullet in the block, which would be the inertia of the bullet plus the inertia of the block, and the velocity of the bullet and the block together. Eerie. It's like number 1. Let's see. Do I know the inertia of the bullet? I do. It's 0.021 kilograms. Oh, I got to make sure I convert things into kilograms, right? Like in the labs you guys did yesterday. Do I know the velocity? Yes. 250 meters per second. I'm going to take upwards as positive, so I don't have to worry about my negative sign. Do I know the inertia of the block? Yep, 1.80 kilograms. And no, kilograms are our base unit of mass. That's why I turn the mass of the inertia of the bullet into kilograms. So, looks like I can find the velocity. So let's see. This I said was 0.021 kilograms. Mine was moving at 250 meters per second. That equals 0.021 kilograms plus 1.80 kilograms velocity BL. I think I got all my numbers right. That's going to give me the velocity of the bullet in the block. Let's see what I get. I want to make sure I got all my numbers right and transferring over. Yes. Okay. I got an answer of 2.88303 meters per second. Now, if I go back and check the problem, did they ask me the velocity of the bullet in the block afterwards? No, they asked me how high it went, right? Well, this tells me the velocity that this block and bullet started moving upwards at. Ooh, as soon as it's embedded, what type of thing does it become? It's a system, and then that system is a projectile. Remember those? Yeah, it's one of those hassles in this class. You can't forget things. You gotta just keep building on your knowledge. So, they want to know how high it is, and so I need to realize that once embedded, the system becomes a projectile. So I've used my ideas here in momentum to find the velocity that this thing starts up at. And now I need to realize that, oh, that's just like throwing a ball up and trying to figure out how high it goes. So I know things like that it's going to be accelerating downwards at little g. How fast is it going to be going at the top? 0, because it doesn't go any higher, right? It's got to stop and then come back down. So I'm going to choose to use that V final squared equals V initial squared plus 2A delta D from our equation sheet. V final, we just said that's going to be 0 meters per second. Our V initial, 2.88303 meters per second squared, plus 2 negative, because it's downwards, 9.80 meters per second squared, and our change in displacement is going to be whatever height it gets to, h. And now I have all numbers, so I solve for h. And that should be my answer. And double check. After all, it is Friday. That's weird. divided by I got 0.424 meters. Yay. Be careful, don't drop the square. Alright, so we're going on to number 4 here, where we've got our 2 train cars that are coupled together by being bumped into one another. Train car. This is kind of like number 1, except both train cars happen to be moving in this one. But our reasoning, our why behind this, our understanding of it is the same idea. That the 2 train cars create a system, that the momentum is going to be conserved in that system, it's going to stay the same, and that we have a before and an after, so we definitely need to look at a diagram. And by doing that diagram, I can also show that I understand that these 2 momentums are going to combine vectorially, or combine with that their directions matter. So my y here for number 4 would have all of those type ideas in it. You know that momentum is ... fill it. The 2 cars are a system. Momentum is conserved. Fill in the rest. How many objects do I have before the collision? How many after? 1. So I'm going to draw my diagram. Start off with my beautiful rendition. Do they label these at all? Train cars coming in, so it's 2. So we have the first and the second. So let's call them F and S. And then our object that we end up with will be the 2 together, so FS. So F is moving in this direction. Well, ooh. Doesn't look like a P. Momentum in that direction. S moving towards it, so momentum. Momentum S. Any thoughts on which one is gonna, which direction they're gonna end up going in? Which way? This way. That's what I think, because I look at the first one, it's more massive and it's moving faster. So I think it's going to have more momentum than the second one. So I agree. I think it's going to move this way. And I know I've truncated a little there on my explanation, on my why, but so system equals momentum after of the system, or prime. Beforehand, I have the momentum of the first car and the momentum of the second car, and afterwards I have the momentum of this new object, first and second. The inertia of the first car, velocity of the first car, inertia of the second car, velocity of the second car equals the inertia of my new object, which is mf plus ms, and the velocity of my new object. Let's see if I know these numbers. Let's see. I have the inertia of my first one, 13,000 for me. Velocity of my first one, positive 0.3. Second one, I know the inertia, 95,000, excuse me. Its velocity, negative 1.2. So they've already assumed for me that to the right is positive and to the left is negative. So at this point, I'm substituting in my values. So 130,000 kilograms, 0.300 meters per second. I'm going to run out of room here. Maybe I should start writing really small. 95,000 kilograms times negative 0.12. 0.12. Yeah. 0.12 meters per second. That all equals 130,000 kilograms plus 95,000 kilograms. VFS. Solve for VFS. If you get positive, it means it's moving to the right. If you get negative, it means it's moving to the left. Give it a try. I'll come around and help as needed.